Hello dear students, so another important question for you people, and the question is find the resistance of a wire of length 300 meter and the cross-sectional area 1 millimeter square made of a material of resistivity 2 into 10 raised to the power minus 7 ohm meter. You people can see on the screen there. Is that okay? So question is very simple. All that is required is you people should be good at handling the units. So I hope all of you are good at handling the units. So let us go ahead with this question. So find the resistance of a wire of length. So we note down the data. So length of the wire, it is 300 meters. So it is an SI unit. We don't have to make any change. Coming to the area of cross section, we have got the area 1 millimeter square, and we know millimeter means 10 raised to the power minus 3 meter square of this, and we get 1 into 10 raised to the power minus 6. So that is 10 raised to the power minus 6 meter square. So coming to the resistivity over here they have given 2 into 10 raised to the power minus 7 ohm meter. Got it? So only thing that was required to be done was conversion. Millimeter, you know, stands for 10 raised to the power minus 3 meter, but here we have got square of that, so we get like that. So coming to the resistance, we know it is given by rho L over A. So everything is given. All that we got to do is put the values here, and 2 into 10 raised to the power minus 7 here. What is the length? It is 300 meters. And in the denominator we have area, that is 10 raised to the power minus 6. So we can write over here 2 into 3. So 3 into 2 or 2 into 3 into 10 raised to the power minus 7, 100 plus 2, and minus 6 goes in the numerator, becomes plus 6. Got it? So minus 7 from here, it was 300, we had taken only 3 here, so 100 was there with us, so 100 can be written as 10 raised to the power 2. So plus 2 here, 10 raised to the power minus 6, when it comes on in the numerator, you get 10 raised to the power plus 6. So we get over here 6, and you can easily see 6 plus 2 is 8, so with a plus sign, and minus 7, so you get 10 raised to the power 1, which is same as 10. So answer is 60 ohms. So that was A part of the question. Now we are coming to the B part of the question, and B part of the question is what happens to the value of resistance if the diameter of the resistance wire is halved by pulling it? Is it okay? So what happens to the value of the resistance if the diameter of the resistance wire is halved by pulling it? Now you people must have seen, in case we take a rubber band and we pull it to make it longer, we find it tends to thin out. That means when you're going to increase the length, it is going to get thin out, or other way around, when it gets thinned out, you find that its length is more. Is that point clear? So just remember that it is not just when you are taking the wire and you are keeping the material of the wire in the same quantity and you are pulling it, what is going to happen? One is the length is going to increase and the area of cross section is going to reduce, or radius is going to get reduced, or diameter is going to get reduced. What is going to remain the same? It is the material which is remaining the same. That means no change in the resistivity. What else is going to remain the same? It is the volume of the wire. What is going to remain the same? The volume of the wire and the resistivity of the wire. So let us proceed to solve this question. We have seen the resistance of this wire was 60 ohms. So resistance of this wire was 60 ohms, and what we have done, we have made it longer and it has become reasonably thin. Now let us see. We know the resistance of the wire is given by rho L over A. We can write this as rho L over pi r square. Is it okay? So we can also write it as rho L over pi r can be written as d upon 2, and d upon 2 whole square will be what? D square upon 4, so the expression comes out to be 4 rho L over pi d square, and I'm calling it equation number 1. Is that okay? Now, volume in the beginning and volume afterwards is going to remain the same. So, volume for the cylinder, you people know it is pi r square. R square can be written as d square upon 4 into length. So, area of the cross section into length, or pi r square into L can be written like this. And now in the new situation we can write pi d dash square upon 4, and we can write L dash here. Is that okay? So this 4 will cancel and pi will cancel both the sides. And now let us see what they are saying. They are saying the diameter of the resistance wire is halved. That means what information they have already given us? They have told us that d dash is equal to d upon 2. Now this particular parameter what they have mentioned is what we have to use over here, and once we use it over here in the above equation, we can write d square into L, and here in place of d dash we will write d upon 2 and square of this, and we have L dash. Now from here you get d square L is equal to d square upon 4 L dash. Cancel d square with d square, you will get L dash is equal to what? 4 times of L. So this is another information that we need. Alright, so now coming to the new value of resistance. So we work it out here. The new value of resistance R dash can be written as what? We can write 4, material remains the same, and you can write pi. And look at this, we want L dash now. What is L dash now? What is L dash? L dash is 4 times of L. And what is D dash? D dash is D upon 2. So we write D upon 2 and square of this. Is that okay? So let us check up once again. So for the new resistance, we have the formula 4 rho L dash over pi D dash square. In place of L dash we have written 4L, and in place of D dash we have written D by 2. We rub it off here and now simplify. So we get the expression here 4 rho L, and we write over here pi D square. This 2 will go in the numerator, and the square of this will go in the numerator. That will be 4, and another 4 in the numerator. You will get 4 more. Let's check once again. So we have got this 4 and this 4 also. So we have used only 1 4 over here. So 1 4 this one, another 4 is coming. So we leave it like this. Now call this R dash. Once again we are writing. We can write this value 16 in front, and the remaining value I am putting in bracket. What is that? 4 rho L over pi d square. Now call it the second equation. Now compare the first and second equation. So from the first equation we can see 4 rho L over pi d square is equal to R, whose value was 60. So we can write 16 into, this is what? Nothing but R from first and second equation, we get that. So it is 16 times of R, and if we take the value of R from the previous part, it is 16 into 60. And what is 16 into 6? 96. So 960 ohms is the answer for this question. So could you understand? So I hope you found it quite interesting. This was a reasonably good level question, but do a bit of practice. I think each one of you will be expert. So thank you and bye-bye.